Hi there, and now we're gonna talk about the mathematical functions or the arithmetic functions. So here you can see on the mathematical function, first thing is the addition, subtraction, multiplication, division. And we can go for the first one, that is the addition. So by taking the addition, you can change the block into your desired one, addition, multiplication, anything. So by default addition, it's okay, and I'm going to use what to add or what is the data type to add. Here you can use that could be integer, double integer or real. Like in the previous video we learned for integer we use memory word, for double word we are using the double integer, and also we are using the memory double word for the real. Real means floating point values. First thing first, we can go for the integer. So as an integer we can add the mw0 for we can add a number, input 1, mw2. I'm not taking mw1 because of the memory overlapping, and the output will be storing in mw4. So here you can see two numbers in 1 and in 2 is added and stores in the out. That means mw0 and 2 is added and stores in mw4. Let's see. So now we are at the runtime, and you can see I'm going to add to mw0 and 2, insert two memory variables, bit memory 1, bit memory 2, and also another bit memory 3. So everything will be in mw0, and here also mw0, and the result will be, mw2 here, and the result will be storing in mw4. So I'm making everything 0 by default, 0, here also 0. So for adding these two memories mw0 plus mw2, like I'm adding 5 plus 6, here I'm going to 6 or 7, we'll be getting 5 plus 7, it is 12. That means mw0 inside mw0 is 5 plus 7 is 12. So let's see, we are going to add the real numbers. Okay, the real numbers means point values. So I'm exiting from here and I'm going offline, and the integer I'm going to change. So the integer I'm going to change into a real. Real numbers means floating point numbers. So in the real you can see these tags are in the red color. That means that these tags cannot be used. So I'm using the double word. Okay, so md0 will be added with md4 and stores in md8 because it is real number. So memory double words can only be used. So I'm going to download, and by adding this function, and you can see that could be md0 and md4, and here we are getting md8, 4 and 8. So we have added, we are not adding these decimals. I'm making everything 0, 0, 0, and we are not adding the decimals. We are actually going to add the point values or the floating point values. So for providing floating point values, you can go to the the real. We can make everything as real. Here also real, and on the last one, on the result, we are also making real. It is actually mentioned in the exponent and manisa e raised to plus 0, 0. That is the form we represent the real numbers in the binary. So I'm selecting all and changing it to 5.6. 5.6. That could be added with 3.7. 3.7. You'll be getting the result as 9.3. You can see 5.6 plus 3.7, which is 9.3. So that is the floating point addition. Like that you can do all these other subtraction, multiplication, division in the integer and the real also. It's very easy. Okay, I'm not doing that up to the division, we can go for the MOD block. The MOD, we can check what is MOD. Up to division, it is simple, like the other for the arithmetics blocks are same for this. We can change it to multiplication, division, or subtraction, whatever. We can go for the MOD. Now MOD, here you can see that can be the type of memory that can be only double integer. It's okay, we can go for the double integer, and it is still we are using a double word memory, MD0, here MD4, here MD8. The input or output which is in the double integer, but it is still not taking. Let's see why. We can go for the PLC tags right here. Here you can see show all tags. We'll be watching the type of tags right here. Here you can see these are the tags which you can see MD0, MD4 and MD8. These are the data types are real. We need to make it as double integer, okay, or double word. See, double word and D word, and here also double word. So otherwise these tags cannot be taken because on this we are using the double integer. Anyway, now the tags are in black color, that means taken. So let's see what is MOD block. I'm not using, I didn't see this. Let's see. MOD means the modulus. Okay, the modulus. That means in the form I'm using the decimal, here also decimal, here also decimal. So everything is 0 by default, storing the previous value 0 0 0. MOD means that is the remainder. Okay, like we are dividing something like this, 5 divided by 3, 5 divided by 3, 1, 3, the remainder is 2. Here you can see the remainder is 2. This is actually finding by the MOD block. So the two inputs will be, in one will be 5, in 2 will be 3. So 5 divided by 3, we will be getting the result as 2 here. Let's check. So MD0, which is 5, divided by 3, we will be getting the result as 2. That is the remainder block.